Okay, we are starting ratios notes 2. Can ratios be equivalent? So similar, we're still thinking that ratios are similar to fractions. We're working them out the same way. And this way is, these notes are showing different ways you can model it too as well. So to start off, we have find the ratio of gray squares to total squares. So if you look to see how many gray squares, we have one right here and one right here. So that's going to be 2. And how many total squares is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the ratio for gray squares to total squares is 2 to 9. 2 gray squares, 9 total squares. And the next question says, if this pattern was double, what would happen to the ratio? In this case, the ratio would be, if you were to double it, it would be 4 to 18. But it reduces to 2, 9, right? So it would be the same thing. 2 to 9 up here. If we were to double the ratio, that means we would have 4 gray squares and 18 total. Both can be divided by 2. It goes back to the original ratio. So it is the same. So it's just like finding equivalent fractions. If you multiply the numerator and the denominator by the same number, that new fraction is now equivalent to your original one. All right, so now we're going on to the exciting part. On the side, as you see, there are different labels on the sides of how we're going to compare the ratios. In the first one, we're doing a tape diagram. So what we are going to do is read the following question, and we're going to set up the tapegram below. What I'm going to try to do is try to pre-draw some of the graphs for you on your notes so it's easier for you to do. So let's read the problem. Audrey and Megan are decorating for a birthday party. Audrey hangs 4 streamers in the same amount of time that Megan hangs 6 streamers. If Audrey hangs 12 streamers, how many will Megan hang? So a tape diagram is similar to what it sounds like. It looks like a strip of tape going down, comparing two numbers. All right. So let's go ahead and I'm going to start by labeling my 2 parts as A and M, which stands for Audrey and Megan, right? So we know that Audrey hangs 12 streamers and she hangs 4 streamers to every Megan 6 streamers. So in this scenario, I'm going to go ahead, Audrey hangs 12 streamers. I'm going to go ahead and box my 12. So they look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So key thing here, she has 12 streamers, but Audrey hangs 4 streamers in the same amount of time that she hangs 6. So I am going to make a part where I'm taking 4. 1, 2, 3, 4. There's 4 right there. 1, 2, 3, 4. 4 right there. And the last 4 right here. Because she hangs 4 in the same amount of time, Megan hangs 6. So now, if Audrey hangs 4 streamers each time, and it says that while Audrey is doing 4 at a time, Megan is doing 6 at a time. So for every time she made 4, Megan has 6. So now I'm using a different color. Use orange for Megan. So now I need to draw at least some groups of 6. So 1, 2, 3, 4, 5, 6. That is one group of 6. So when Audrey made her 4 streamers, at the same time, Megan made 6. So this time when she started her 4, you're going to add another 6. 1, 2, 3, 4, 5, 6. That's another 6. And Audrey hung another 4. That means Megan hung another 6. 1, 2, 3, 4, 5, 6. Another 6. So the question is, how many will Megan hang? Well, how this relates to a ratio, every 4 streamers that Audrey had, it was 6 to hers, right? So now I need to count how many did Megan ended up doing. That's 6 times 3. She had 18 streamers. All right. So this is a visual way to see. In this case, if we wanted to write like a ratio for it, it would be 4 to 6. Because every 4 that Audrey did, Megan did 6. So if technically what was happening, how we got 18, if you think about it, how many times did Audrey hang? She hung it 3 times. If you multiply 4 times 3, she had a total of 12. If you do 6 times 3, she had a total of 18. And 18 was our answer. You see how that worked? She hung up 4 streamers 3 different times. She hung up 6 streamers 3 different times. And that's how the ratio would look. All right. Now the next one is, sorry, let me skip this over for you guys to see. Double number lines. So this one you will see in other grade levels, especially for years to come. I'm going to definitely make this on your paper before, because you guys, I know y'all don't know how to draw straight lines. So in this scenario, it says, in the computer lab, there is 1 PC for every 3 Mac computers. If you wonder what a PC is, it's like a regular computer, like the desktop computers. If the computer lab has a total of 24 computers, how many are Mac? All right. So to start off with our double number line, I'm going to label it PC and Mac computers, right? I'm going to draw this long line right here, and that represents 0, 0. That's where we're starting off at. So there's going to be a line for PC and a line for Mac. It's exactly what it's saying it is, a double number line. All right, so you have to figure out how many Macs there were with 24 computers. So PCs are computers too. So the ratio I'm going to put is 1 PC for every 3 Macs. So the ratio is 1 to 3. I'm going to just write that to the side. So I know my PCs are going by ones, right? So I'm going to start right here. If I have 1 PC, sorry guys, my screen was going blank. If I have 1 PC, that's a little dash, like a tick mark. If I have 1 PC, I have 3 Macs, right? Because for every 1 PC, there are 3 Macs. Now I'm going to make my tick marks all the way up to 24. So now if you have another PC, I'm going to go ahead and label all of these up. If you have another PC, how many Macs would you have? You will have about, for every, so if you had 2 PCs, how many Macs would you have? So if it was 1 to 3, that's basically doubling it, because 1 plus 1 is 2. If we double it, that means for every 2 computers, we have now 6 Macs. Keep in mind, we're trying to get a total of 24. So when you add those 2 right there, that's 4 computers total. If you add 2 and 6, that's 8 computers. We have to get all the way to 24. So if we keep going, if there was 3 PCs, there would be 9 Macs. 3 PCs, 9 Macs. So if you look at it, honestly, from 1 to 3, you're multiplying times 3. From 2 to 6, times 3. 3 to 9 is times 3. So let's keep going. If we have 4 PCs, we know that we're going to have 12 Macs. Multiplying it by 3. So let me write that down. So 4 to 12. 9 and 3 make 12. 4 and 12 make 16. We're not at 24 computers yet. So we need to add another PC. You have 5 PCs. You have 15 Macs. So 5 and 15 make 20. And we are almost there. If we have 6 PCs to 18 Macs, because you have 6 and 18, 6 and 18 make 24. So it says, how many Macs are there? 18 Macs. Because when you have 6 PCs, you have 18 Macs, and when the total of computers, 6 and 18, make your total 24. All right. Last one are tables. Something you guys are similar to something that I was doing on the side. So the ratio of men to women at a car wash is 4 to 7. What is another combination, men to women, that the car wash could have? So I'm going to use a different color. I'm going to make a table, and it's going to show men to women, because that's what we are comparing. You are trying to figure out what's another combination, another equivalent. So you know that whenever there's 4 men at the car wash, there's 7 women. All right. So think about it. Just doubling stuff. So if you were to double 4, you have 8 men, double 7, 14 women. Just like we did at the top of our notes, 2 to 9, 4 and 18. When we reduce 8 to 14, you will get 4 to 7, your original answer. So as I see, from here to here is plus 4, and here to here is plus 7. So what if I keep adding 4? 8 plus 4 is 12. Add another 7. 7 times 3 is 21. Okay, 7, 14, 21. So there's a pattern. Still the same ratio, because if I simplify 12 and 21, it will be 4 and 7. So you're just making equivalent ratios. So I'm going to add another 4, 16 to 28. All right. So I want you to go ahead and tell me the next 3. All right. So what will come after 16? Three more times after that. So pause it and figure out what the next 3 ratios will be. All right, so the next 3 ratios, after 16, it will be 20. It will be 20 compared to 35. And then you'll have 24 to 42. And you'll have 28 to 49. Those are the next 3 ones. Remember, this one is getting bigger by 4 each time. This side is getting bigger by 7 each time. All right, tables are really simple. I think tables and tapegrams are the easiest. Double number lines are okay, but it requires you to make sure that your tick marks are on target for each other. So turning on the back, It says choose one of the methods and determines if the ratios are equivalent. So the three methods that we just did on the back, if you were to do tape measures or the double number line or the table, that's what you would do. All right. So in this scenario, or honestly, you can simply say, do the two numbers, can it be simplified and the other one equals the other one? Because that's how you can figure out if it's equivalent. So you have 7 to 11 and 15 and 46. So I'm looking at, does 7 and 15 have anything in common together? Can they be, do they have any same factors? They do not. 11 and 46, you know 11s are doubles, like your 22s, 33s, 44s, all of those. So in this case, 7 to 11 and 15 to 46 are not equivalent. They are not the same. You cannot go, I'm going to just label it X and Y. You don't have to, but you can't go from 7 to 11 to 15 to 46. That is not equivalent. So number 2 says 5 to 6 and 10 to 12. So easiest thing for me to do is set up a table, 5 to 6, 10 to 12. And I'm looking at it, all right. So I have 5 to 6 and everything got doubled. 5 plus 5 is 10, 6 plus 6 is 12. Is that equivalent? Yes. This one is equivalent because when you divide both of these by 2, you go back to your original 5 to 6. So those two are equivalent. And the two parts that where it says, how do you know? Well, let's start with this one. How do you know? You would say numbers are being doubled. And how do you know this one? There's no relationship between numbers. All right. I want you to do 3 and 4. I want you to compare those two numbers to see if each group is equivalent to one another, and we'll come back and talk about them. All right, for number 3, where you have 18 and 12 and 3 and 2. 18 to 12, 3, and to 2. The first thing I'm thinking about, what can both of these be divided by? Both can be divided by 3 and 6. So if I was to divide 18 divided by 6, you would get 3. If you divide 12 divided by 6, you get 2. Are they equivalent? Yes, they are equivalent. Both can be divided by 6. This is one of the equivalent fractions of it. So if you were trying to reduce 18 to 12, you would divide both 18 and 12 by 6, and you will get 3 and 2. So those are the same ratio. Those are equivalent ratios. Over here, 39 and 21 and 7 and 13. I'm going to line up my numbers. And just sometimes, by just looking at it, you can tell 39 and 7, they can't be divided by anything. You can't divide anything by 39 to get 7. Same thing with 21. You can't divide anything by 21 to get 13. So there's no relationship between numbers. All right. So sometimes you can just eye ratios and say, no, it can't be simplified. That's not equivalent at all. All right. Sorry, guys. I got to push this to the bottom. All right. Our last two problems for number 5 and 6. It says the lemonade mix calls for 2 tablespoon mix for every 3 cups of water. If the container has 24 tablespoons of mix, how many cups of water will be needed? So this is kind of like a table one that we're going to do. And we're going to say we need to know comparing the mix and water. All right. So now we know that for every 2 mixes, there are 3 cups of water. So how this would look is if you have 2 tablespoons of mix, how many cups of water is that? That's 3 cups. So now every time you're adding another 2 tablespoons of mix, so you're basically doubling it. So if you had 2, if you double it, you have 4 tablespoons of mix. When you double it from 2 to 4, you double the water. Now it'll be 6 cups of water. And we have to figure out if the container has 24 tablespoons of mix. So this table has to go all the way to 24 to get how many waters we're going to get. So I'm going to start writing these a little bit smaller so I can fit all this on the screen. So you're adding another 2 tablespoons of mix. Now you're up to 6. You're adding another 3 cups of water, which is 9. Do you see the relationship right here? All right. Sorry, from right here to here. You're adding 2 each time, and this time it's getting bigger, plus 3 each time. All right. Now, moving on, 2 more cups of mix, 2 more tablespoons, sorry. You have 8. Add another 3 to 9 is 12. Same thing, add another 2, you have 10. Add another 3, you have 15. Add another 2, add more 3. So all I'm doing is adding 3 to the bottom. Each side is getting bigger, and at the top it's getting bigger by 2. Add another 2, you have 14. Add another 3, 21. So I'm going to just go ahead and mark it's going to go 16, 18, 20, 22, 24. Right? So I just need to fill out my cups of water. I'm getting bigger by 3 each time. That's 24, 27, 30, 33, 36. So this is my target answer because we were trying to get 24 tablespoons of mix. So when I have 24 tablespoons of mix, it wants to know how many, sorry, my alarm went off. So I want to know how many cups of water. You will have 36 cups of water. All right, and that's doing it with the table because we have to get up to 24 tablespoons of mix. When we have 24 tablespoons of mix, the ratio will be 36 cups of water. All right. So working on the last problem, it says, on his math facts quiz, Jeremy missed 2 out of 11 questions. The next quiz has 55 questions. How many can Jeremy expect to get correct? Same thing if you were lining it up. If you just line it up how many he missed to questions. If he missed 2 out of 11 questions, it's saying on the next quiz he has 55 questions. So you know how many questions. You're trying to figure out how many you can expect him to miss. Now you have to think about it. How can you jump from 11 to 55? Can you jump from 11 to 55? Yes. That's times 5. All right. So now you have to think about what is equivalent to 2, making 2 out of 11. thinking about fractions, equivalent fractions. So you have 2 over 11 to get to 55, right? So if this was times 5, you can bet that he's going to make 5 times more. So he would miss 10 questions, right? Because 2 times 5 is 10. That will complete the ratio. But it says, how many can Jeremy expect to get correct? Well, if he missed 10 out of 55, what's the other portion? So you would subtract 55 minus 10. He would actually get 45 questions correct. This one was kind of a two-step. It didn't want to know how many he was going to miss. It wants to know how many was he going to get correct, right? So you can set it up as a fraction to help you, right? Because they gave us the first part, which is 2 out of 11 questions. He was going to get 2 wrong out of 11 questions. So now it said, okay, what if he had a 55 question test? How many would he get right? Well, set it up as a ratio. You know, from 11 to 55, you would times it by 5. So you would do the same thing over here to make the ratio balanced. Will be times 5. So 2 times 5 will give you 10. So you subtract the 10 he missed, and you'll figure out how much he got correct. So at the bottom, as usual, do your 2 to 3 sentence summaries for that, and you can definitely talk about the 3 different strategies that you learn how to see if a ratio is equivalent. And I'm going to go ahead and pull up your homework as usual so you guys can see what you guys will be having to do for homework. All right. So let me zoom out. In all honesty, guys, that's probably the easiest unit, especially when it comes to homework. It's exactly the same thing. Our notes were set up just like this. We have our 3 different methods that we're going to use, and we're going to practice determining if it's equivalent or not. I suggest you guys set up tables like 4 and 18 and 2 and 12 to see if both of the sides have to be doing the same exact thing, like if it's being doubled, if it's being tripled. If it's not, that means it's not going to be equivalent. So you have to do 3 of these, the same ones, type of ones that we did on the back. And you have 3 word problems to solve. Remember the tapegrams we did, tape diagrams, the double number line, and the table. You probably guys would do better with the table one, but I want you to try all 3. If you don't understand these, guys, go back and watch how I did the tapegrams and the double number lines in the table. All right, you have your resources, so use it. All right, so if there's any questions, let me know.